This is going to be a video on slope to help with some of the 6LA foundational exams. So to just cover a previous video quickly, we're going to take some function, we're going to graph it, and this function takes a number, x, and spits out that number doubled plus 1. So if you hand it 1, it'll double it to 2 add 1 is 3. If you hand it a 2, it'll hand you back a 5, because that's one more than double it 4. 3 gets doubled to 6, add 1 is 7, so on and so forth. The pink numbers here are called the domain, the green numbers here are called the range, and the function is what takes as input something in the domain and hands you back something in the range. The way I like to think about it is you can think of the domain as all your ingredients, like in a kitchen, and the function is like a chef, and the output, the range, is like food. So you hand ingredients to a chef, and they hand you back food using the ingredients. So if we graph this here, so I've graphed 0, double it, add 1 is just 1. So 0 goes up to 1, 1 goes up to 2, 2 goes up to, 1 goes up to 3, 2 goes up to 5, and 3 goes up to 7. Now, this line has a slope of 2. And, well, the idea of slope is that it lets you measure how steep a line is. So the idea is that a height, if you imagine yourself as a little person trying to walk up this hill here, a very large slope in the math sense means a very steep incline. And a lower slope means a flatter incline. And so the way you calculate this is, let's take a little portion of the line here and zoom in on it. Imagine if we move, if we're maybe a little ant sitting on this plane here, this flat surface. If we scuttle along 2 units, I don't know, let's just say this is an inch, 2 inches to the right, how far would we have to scuttle upwards to get back to this slope we were on? Kind of like if you were trying to cut, so if this is like the hiking trail, if you cut perfectly sideways and then try to go straight up the mountain, if you went, say, two football fields off the side of the trail, how many football fields would you have to go up? In this case, it's 4. So if you go 2 to the side, you got to go up 4. And you can see that because this function doubles numbers, and then adding 1 really only has the effect of sliding the line upwards slightly. So if we had done 2x minus 7, we would get the same slope, but this line would just be shifted downwards. In fact, I can draw that in. I don't know if this is exactly correct, but something like this if we had 2x minus 7 as our line instead. So it'll be y. And then sometimes this will be labeled with f of x, sometimes with y. It just depends on the problem and what class you're taking. And then sometimes it's easier on your brain to, instead of writing out with what's called functional notation, so f of x in parentheses equals such and such, you just have your input, an arrow, and then the output. So the formula then for how steep something is just how far you had to go up divided by how far you went sideways. So in this case, rise over, and that's where the rise over run kind of catchphrase comes from. So we get 4 over 2, which is just 2. And so similarly, if we had the other case where you moved 4 to the side and then moved up, should be consistent with my colors. So if we went 4 to the side and then 2 up, this would give us a slope of 2 over 4, or 1/2. So you can draw that in here as well. So here's a line with slope 1/2. And so a line with slope 0 means a line that doesn't rise at all as you run along it. So here's 0. And then this isn't perfectly correct, but if you have a line that's perfectly vertical, the rise is endless for no amount of run. Run just means moving side to side. So this would be, if you go back to the hiking metaphor, this would be like climbing a perfectly steep cliff face. It's just a sheer flat surface vertically. And so you could kind of think of this as having an infinite slope. And then similarly, if you have lines that are pointing diagonally downwards, So this could have a slope of like -1. We could have a slightly steeper downward slope. And so the slope also sort of depends on which direction our hiker here is walking. If they're walking uphill, the slope will be positive from their perspective. If they're walking downhill, it'll be negative. And usually we imagine the hiker as walking from left to right through our little graph here. So this could be like -2. Then we could have a slightly less steep. I'm running out of space here. And so this could be like -1/3 maybe. We could have a very steep. So this could be like -7. Yeah, and that's the idea with slope.